All right, welcome back. I'm Bill Westlake, and this is Lag Demon Programming. We're working here on some C++ tutorials. In the last week, last set of videos, we worked on a game, a very simple game called Rock, Paper, Scissors. And what we did in that was we created a what's called a REPL, or read, eval, print loop. What we're going to do in this set of lessons is we're going to make a different kind of game, a very simple text-based game still in the console, and it's going to be a little dungeon-style game where you go from room to room and you read descriptions and you give commands and so forth. But we're going to do it a little bit differently. We're going to start learning about classes and inheritance and virtual functions in these lessons. So thanks for watching, and I hope you enjoy the video. Well, the first thing that we're going to do is create a new project. And it's going to be the same. It's going to be a console application. So that's right here, Windows C++ console application. Click Next, and I'll make sure I'm in the right place here. I'm not. We want to be in... it's not CPP course projects video. That's the one we want. Okay. Got a lot of directories there. So what are we going to call this? Well, we'll just call this we'll call it Dungeon Crawl. That's a fairly common name for this style of game. Alright, so let's create that project. And again, all of the source code for all of these projects is available on in the GitHub repository. There will be a link in the video below. You can go out to GitHub and see all the source code that we write here. I'm going to again get rid of these comments. We don't need that. So we're not going to worry about the main function just yet. What we're going to do first is create a class right off the bat. And I'm going to use... we could do create class here, but I'm going to do a new item because I have a template-based class here. I called it MIT class because it contains the MIT open source license. So what we'll call this first class we're going to create, we're going to call game. And I'm going to take this CPP file and drag it down here to source files. Again, these are just filters. All of these source files are actually all in the same directory under your projects. These just let you organize them here. All right. So we have game.h and we have game.cpp. And we don't need, save that. We don't need Dungeon Crawl right at the moment. So let's open up game.cpp. All right. So a class, a header file, is where we will define a class, and the CPP is where we can put the implementation of that class. Now, you can also put some implementation in the header file, and we will get to that. Those are those functions are inlined. They're read as part of the header file. We're going to start by separating them out, which is the very common thing to do. There's some other circumstances where we would want to do everything in the header file, but we're going to separate them between the here and the header file. So what do we think a game is? Well, this is a very general idea here. We want to think in kind of abstract terms. We want to think about our read, eval, print loop and what all it's got to do. So we need to, again, we'll write out some simple requirements here. We need to display something, display a description of the game initially when the game starts. We need to then enter into some kind of a loop. So we'll say this. Well, this is 1. We'll do 2. We need to start up some kind of a loop, and in that loop, we're going to display a prompt for this game. So that's going to be some supplied by the user of this class. Now this user is not the end user, the player. This user is a programmer that might use this class to build another game, and that will be us. In a future video, we'll reuse this class. We want to read some user input, and that's all pretty straightforward and can be done. But number 5 is where we need to pass that user input to a function specific to the game, and I'll explain how that works. And then 6, we will receive result and get a result, and we'll get a result in an object, and then we need to print the result. And then 7, we're going to be going go back to 3 and display the prompt again. All right, so those are the kind of the general things that we need to do. So that's the requirements that we're going to fill. Oh, by the way, this is the banner for the MIT license. This basically just says that you can use this software for whatever you want. You can read it in detail. You can go online and look at the entire MIT license. All of the source code that I produce will have this license applied to it, and the repository has the MIT license applied to it. So you're free to use the code in any way you want. All right. Let's talk a little bit about, now that we've got our requirements written, you know what, I'm going to pull these out of this class body where I typed them. And I'm going to put them up here above the class. All right. That was kind of a bad place to write the requirements. All right. So this is the basic definition of a class. You can see what it says here. It says class, that's keyword class, and then game is the name of this class. And there's an open and closed parentheses in the header file, followed by a semicolon. And this is all in the header file. And then we have this statement here, public. By default, everything between these parentheses would be private to the game, class. And we'll explain public and private a little more generally as we go on. But public basically means that the outside stuff creating instances of this type game can call methods or gain access to data that's under the public, listed after public. And you can arrange these in different ways, and we'll do that shortly. This special method right here is called a constructor. It's got the same name as the class name, and then it can have parameters associated with it. And our parameters, we want 2. I'm going to come up here and include string. We want to send 2 parameters into this. The first one that we want will be a standard string called the name of the game, a standard string called the description of the game, and a standard string that is the prompt to display. So these are the parameters that you can send when you construct this class, or you must send these parameters when you construct the class. And now that's in the header file. It's defined here. This is the CPP file, and you notice we're including the game header file. And I'll describe this in a second. Let me put these parameters in. We got a list of the parameters here as well. This is saying we're writing the definition of this class. This is the declaration of the class and the declaration of the game constructor. This is the definition. of that, or the implementation. This is what's going to be in there. Okay. Now we don't need to do much here, because all we're going to do is keep these variables aside. Actually, we'll do it down here. So what we want to do is create some members, and we're going to make these members protected. And so protected means that classes derived from this class can also access that data, whereas private, it's to that particular type only. We'll demonstrate these things as we go through. Now I use a convention. Not everybody uses this convention, but I like it. We're going to create standard string underscore name, standard string underscore description, and standard string underscore prompt. So the underscore just informs that this is a protected or a private thing. It's not something that is public, and only classes and derived classes are going to use this. These are the storage types within it. So in the previous one, we looked at a struct, and we had some types within there. A class and a struct within C++ are essentially the same thing. These are data storage within this class, and they're protected, so only the class, only functions, methods within this class or derived classes can access these directly. All right. So in here, what we're going to do is we're going to initialize those. And the way we're going to initialize them is by putting colon, underscore, name, and pass in name. Underscore description, and we'll pass in description, and underscore prompt, and we'll pass in the prompt. And then we can actually move this stuff below here to make it a little bit neater and put this up here. So this is basically saying there's no function body, nothing's going on in here, though we might put something in later if we need to initialize some other things. What this is saying is when we construct it, we're going to pass in the name, the description, and the prompt, and the constructor is going to store the name in this value name here, called underscore name. It's going to initialize that with that name and with that description. And in this case, we're passing in by value a string, and it's going to make a copy of it. And it's going to put that copy into name. So this is an independent copy of those things. We don't have to worry about storage or disposal or anything else. They're stored as a copy within this, and whatever we passed in can be a constant or whatever it may be. All right, so let's make something very simple here now to just ensure that we got those things. We're gonna create a function here called print banner, and we're gonna make it. It's gonna return void, and this banner is going to be very simple. We're gonna copy this. Well, actually, there's something. Let me show you a tool in Visual Studio here. You see this little icon over here. I think it's a little screwdriver. It's tools, and it says here create definition of print banner in game.cpp. Remember I said what's in the CPP are definitions, and what's up here in the header file are declarations. This allows us to create the definition just by clicking on it. And when I click on it in Visual Studio, it actually opened up game.cpp. It put the text in there, and that's actually in there. Now I'm going to close this little window. This is a little preview window. You can actually edit in here. We can go in and do stuff. But I'm going to close this, and we're going to go over to game.cpp, and you'll see that print banner has been laid out just like we did this one. Its return type is void. It's put the game : in front of it, print banner, and the 2 parentheses automatically for us. Saves a little bit of typing. You don't have to come and retype all this stuff. Visual Studio's got a lot of very nice tools like that. So what do we want to do for print banner? Well, let's start by coming up here and going include IO stream. All right. And let's go standard C out from underscore name. Let's put a space and then underscore description. And then all right. Now if we open up our main function here, we can get rid of this hello world. We want to include game.h. There it is. And let's create the object. We can just go game, but we have to pass it some things, and we're going to call this dungeon crawl v 0.1 is the name of it. We're going to pass it, we got to include string. Dungeon crawl, the description, a dungeon crawl game, and we'll pass it a prompt. It'll be command like that. All right. Now we can call game dot print banner, and that should print out all this information, and we'll walk through that and see what that is. So let's run it and see what happens. Dungeon crawl version 0.1, a dungeon crawl game. Printed it out, and it ended, of course, because we're not doing anything. So what did it do? Let's take a look here. It printed out those values, name, description, which we have here. Name and description. It printed out those values showing that the name we passed in and the description we passed in and the prompt got saved into those. So there's our print banner. And actually, let's go modify that slightly and put in, so we put out the name, let's put the description, let's make this and then let's do another one of these, because the next thing we're going to do is the prompt, and we want a little space in there. All right, so let's do print prompt. All right, so if you remember, okay, well, we can do this with our little tool here, create the definition. We'll close this one, we'll go work in the main file. There's our print prompt. If you remember, when we print a prompt, we can go standard C out from prompt, which is all fine, but now we need to go standard C out dot flush, or it won't display. It'll be waiting for that end of line, and we don't want an end of line. We want our cursor right after the prompt, so that they can type in right at the prompt. So let's go back to here, and let's go game dot print prompt. Let's see how that looks. And we'll do this differently. We're just testing our software a little bit at a time here. So there we have our dungeon crawl version 1.0, a dungeon crawl game, and command, and we've got our prompt printed out. All right. So let's look at our, so we haven't got to the loop yet. We'll create the loop later. We've displayed a description of the game. Let's X that one. We haven't really gotten into the loop yet, but we can now display a prompt. All right, so now we want to read some user input. Well, this is a little more tricky. So what we want to do here? We're going to want to read some user input and then pass it on to another function to evaluate that user input. But we're writing this class is not going to be our dungeon crawl game. You notice we didn't hard code the name in here. We put the name over here. We're telling game that it's now a dungeon crawl game. We're not actually going to use game. We're going to use a subclass of game. But for now, we're just firing up game. We need to read the user input and pass it into a function that can be processed by a subclass of this game. But we want to read the user input. So let's go void read input. Now we could store this. I'm going to go standard. I'm going to return a string from this, read input. All right. So let's create that definition. It looks like it didn't pop it up for me that time, but it's here. Here's our read input. All right. In our previous one, we used read key. Get line, not read line, get line. We use get line. All right. So I think get line. Yes, it is here. So standard string line equals get line equals. And what doesn't it like about that? Oh, that's right. GetLine doesn't work that way. Standard : getLine. Do we need to have that? I think we need a header file for getLine. Is it an S stream? String stream? Yes, I think it is. Yes. All right. We need to send it a reference. We need to send it CN, and then we need a reference to a string. That's right. Standard string line. There it is. And then what we want to return is line. All right. So this method in this class will read the user input into a string from CN called line and return that line. Got it. So let's go back to here and we'll test that one. Game dot read input, and we'll go standard string input equals game dot read input. There we go. And then just for the heck of it, we'll go standard cout from input. Standard endl. All right. Okay, there it printed out our heading, and we've got a command now. This is a test, and it printed this as a test, so it got it. All right. Now, a virtual method, and this is going to be important. This is where we're going to change what we do over here a little bit, because we're going to have to create another class. Because At this point, we are going to make this class into an abstract class. And that's important. What it means is we will no longer be able to do this. We won't be able to instantiate game. We'll have to instantiate a subclass. To do that, we're going to use what's called a pure virtual method, and we're going to call it, well, we want this to return something. For the moment, we'll make it we're going to use the keyword virtual. Void eval command standard string command. Now there's two ways we can do this. We can just put an empty implementation in here like this. This is a virtual method that we can override. Our current code will still work. It'll still compile even though we have this virtual command in here. We can also come in here and make this a pure virtual method by saying it equals 0. This says that it has no implementation, and if I attempt to run this now, it's going to fail to compile. And the reason it fails to compile is game cannot be instantiated. So if we look here, it says object of abstract class game is not allowed. Okay. So let me think about that. We could test out a few things here. Our evaluation is what's going to drive some other game. For the moment, I'm going to leave it like this so that we can continue to use this class. And we may make it a pure virtual later. But right now, eval command doesn't do anything. We've got all the basic pieces. We're printing a prompt. We're reading input, and we've got we're reading the input, and we've got one last thing that we need to do, and it also needs to be virtual void, and it's print result. And this is probably going to take some result object, and it's also going to be virtual, and we're not going to give it any implementation here because we're going to implement it in a subclass. So what does this do? Let's begin documenting this. Base class for games using text input and output with a REPL. So this is just a base class to get that, to kickstart that process. The two important things are eval and print, which are the only two things that we need to implement in a subclass of this. However, we also need this to drive a game loop. So what we're going to do is create a function now. It'll be void, and we'll call it game loop, and we'll implement it in our CPP class. We'll close this, go over here. Here's our game loop. So what do we want to do? The first thing we want to do is print banner. That starts the game. Then we'll go while true. And one of these commands hopefully is an exit that will break out of this loop. Actually, we'll come and clean that up later and make sure that that happens, but for now we'll just make it an endless loop. When we've got blocking going on here, this really isn't a hassle, since we're going to have this read input inside here. It's going to block on each loop, so having an endless loop like this isn't a big deal. We can very easily kill the program. So the first thing inside the loop we're going to do is print the prompt. Then we're going to read the input, but we're also going to call this eval function, and it takes a string. So we can combine those together and say we want to eval command read input. And that's it. We have our basic loop. And let's make a default, actually let's make a default print result. Well, the eval command, let's make a very simple default here. Do I have standard IO? Or IO stream rather. And let's make the eval command for now standard cout command. So basically it's an echo machine at the moment. Now we don't want to call all this. All we want to do is call game loop. And that'll start it. So now we have kind of the basic framework of a game. There's a command, we can type something, it prints it out. Whatever we type, it prints it out over and over again, it loops. So this is kind of generically, or generic's kind of a bad term, it's abstractly going through this process. It's running the process at the top level. And that's kind of what we call an engine. It's a piece of code that's driving a process where some other code is going to specialize that process. And I'll show you how to do that right now. So now, obviously, we don't want this default behavior. We don't want to just print out the command. We want to actually do something when we get a command. So what is some of the commands we're going to do? Well, let's create another class. Let's go up here and we'll add a new item. I'm going to choose my MIT class again, and I'm going to call this dungeon crawl game. So this is going to be the game class for this dungeon crawl, and again I'm going to pull this CPP file down to the source files filter. So I like to put my H files to the left of my CPP files. All right. Well, first of all, we want this to inherit game, so we need to include that header file. And game.h. And so the way we inherit another class, this class is going to inherit game, so we want to go a colon, the keyword public, meaning we're going to publicly inherit it. There's some other inheritance modes, but for now we're just going to deal with public inheritance, and what we want to inherit is game. Now, because we inherited game, we better have a constructor that takes the necessary parameters, or we can just call that constructor, and we can actually do that from here. We can go here and we can go game, and we can put in our description from here. We can put all this in. So we'll do it this way for the moment. I'm going to get rid of this here. Let's go back to here. Let's put that data right in here. We'll do this differently later, but this is the dungeon crawl game now. So it can just tell the game, this is what I want you to be. This is what I want you to display. And this is my prompt that I want. Now we can do something here with game.h, is we can get rid of this. And we can put =0. Now it can be an abstract class. This is one that they can't be implemented itself. We can go back here to this one. Instead of including game, we'll include, why isn't it showing up? Dungeon crawl game. And instead of game, we want dungeon crawl game. Now that can be implemented. And we don't need to pass it anything. And game.game loop, that should work. Let's see. I don't know why it's showing the squiggly there. Oh, I didn't implement the... Okay. Getting a little bit ahead of myself. Okay. So you notice we couldn't implement it because this is now an abstract class, because we made game an abstract class here and we haven't implemented those. So let's implement them. So let's go back to game and grab these two things. Put them here. Very simple. But we're going to get rid of this and get rid of this because we're going to implement them. And let's implement them in our CPP file. Close that. Let's implement this one as well. Close that. Now we've got the ability to do this eval and print result. So for the moment, what we will do is we'll go get our IO stream functions, and we'll go standard. And I'm going to put a little remark here: dungeon crawl game colon, and then our command, and then standard and del. And print result we won't worry about at the moment. Now we should be able to run it. And the difference is, no, why can't we run it? Okay, yeah. When you have a constructor with no parameters, and you're doing this way, you don't need to put you can't put the parentheses after it. It thinks it's something else. Used to some other languages, and I get confused. C++. If your constructor on your object, in this case the dungeon crawl game constructor, takes no parameters, it's called the default constructor. We're creating it here, right inside this main loop. It's not a pointer or anything else. We're not doing new. You don't put the parentheses. All right, it should run now. So we get a prompt and we type something in. You notice it says dungeon crawl. So it's calling that method in our second class, in our new class. But it's also using the methods in this other class. So up here in game, it's using this print banner, and it's going through this while loop. We're calling that, even though we're calling game loop on this new class and we never defined it, it's inheriting it. So this is what we mean by inheritance. Dungeon class.h is inheriting game here, and it's inheriting everything that game has. It's inheriting the name, the description with the underscores. It's inheriting all this, and it's inheriting all of these methods, and it's overriding these, which it has to because they have no implementation. So it's actually implementing these abstractly. And so when we call the loop, this code inside game.cpp here, this loop is running. It's calling eval command. Eval command is a virtual method on this class, so it's calling this one here. is calling this eval command on our dungeon crawler game. And we are 40 minutes into this video, so I think we're going to end this video here, and we're going to pick it up next with focusing on this eval command and how we're going to use this to parse out some commands and decide where we're going and what we're going to do inside the dungeon crawler. So thanks for watching. I hope you enjoyed the video. If you really liked it, hit that like button, and if you want to subscribe, I would definitely appreciate subscribers, so please subscribe. And if you want to get notifications, hit that notify button, and I will see you in the next video.